Hello everyone, Albus here. Today, I'll be explaining how changes to a quadratic graph's variables, a, b, and c, will cause a quadratic graph, such as this one, to differ from a basic graph in terms of its shape and composition, its discriminant, and its respective solutions. Firstly, input A determines the shape and orientation of the graph. For example, when a equals positive 1, the graph would have a minimum point and would have a U shape. In contrast, when a equals negative 1, the graph would have a maximum point and would have an upside down U shape instead. In other words, input A inverts the graph vertically about the x-axis depending on whether it's positive or negative. It also influences the vertical and horizontal shift of the graph as seen by this equation. Speaking of which, input B influences the horizontal shift too. By using the completing the square method, we can determine that the horizontal shift of a graph is given by negative b divided by 2a. Input B also influences the vertical shift of the graph. Likewise, input C influences the vertical shift. By using the completing the square method once again, we can determine that the vertical shift of a graph is given by c minus b squared divided by 4a. To give an analogy, if the graph was a stage spotlight, input A would primarily affect the direction of where the spotlight is facing, while input B would affect whether the spotlight is on the left or the right. Lastly, input C would be the one determining the height of the spotlight from the stage. Moving on, depending on the values of A, B, and C, the discriminant of the graph would also change, with the value of the discriminant affecting the number of real solutions. If the values of A, B, and C are 1, 4, and 5 respectively, for example, the discriminant is negative. Hence, the graph would have no real solutions. If the values were negative 1, 4, and 5 respectively, the discriminant is positive. Hence, the graph would have two real and distinct solutions. Lastly, if the values of A, B, and C were negative 1, 0, and 0 respectively, the discriminant is equal to 0. Hence, the graph would have only one real and repeated root, and thus one solution, as it touches the x-axis only once. This is all because the number of solutions, as well as their distinction, is determined by how many times the graph intersects or touches the x-axis, or the graph y equals to 0. To give another analogy, think of the shape of the graph as a trajectory of a boomerang, with the x-axis being a row of targets and the discriminant is your aim. If your A is perfect, like positive discriminant, the boomerang strikes two separate targets, or two real and distinct solutions. If it just grazes 1 or 0 discriminant, that's only one real solution. And if it completely misses, that's no real solutions.